In this series, we'll build a real working LLM benchmark together with AI coding agents, without the usual thrown together in an hour vibe coding, and without manual busywork wherever it can be avoided. This is the first video of a short series. Today we're laying the foundation of the project. I'll try to find a balance between brevity and usefulness. My videos are going to be fairly short, because you don't need to copy everything after me one-to-one. It's enough to understand the main principles and approaches. I think this video will be more useful to developers who already have programming experience, but not much hands-on experience with AI coding agents. If you don't have programming experience, this video can still be useful for you. You can just simplify some moments for yourself. Let's quickly clarify what AI coding agents are. An AI agent in general is a fairly autonomous AI assistant that can make its own decisions about what and how to do, relying on the rules, permissions, and limits you give it. And let me say right away, when an agent asks you for advice, asks permission, or asks you to make some choice, that is also a decision of the agent, done to validate the chosen path of solving the task. In coding, there are already plenty of agents, for example, CLAUDE Code, Codex, Github Copilot, op.md, and many others. They can work inside their own UI, in a CLI, and sometimes even inside a chat app. That's not really important. It's just the way the user interacts with the agent. In this and following videos, we will be working with CLAUDE Code and GitHub Copilot with different models, which will give us the most effective result. And I should clarify that my approach to working with AI assumes thoughtful work and a quality result. Our goal is to build a simple project on a reasonable budget, thoughtfully, with a simple front-end, back-end, and database, and to prepare it for further extension. We will be building a web app called Battleship as an LLM benchmark to produce a leaderboard of the strongest LLMs that are good at understanding images and making strategic decisions for this game. The LLM's job is only to shoot at the game board, taking previous shots into account. Intro is done. Let's get to initializing the project from scratch. And yes, the process is deliberately not fast. We're laying a foundation, not racing to the first screen. In the description of this video, you'll find a link to the project on GitHub. You don't even have to clone it. You can just read it and use it as a reference. And yes, I've already done the whole process for this video, so we don't have to spend time on live coding. I'll just walk you through the workflow and the overall sequence of steps. First, look at the init.md file and install the tools you need. If something doesn't work, hand the link to this file over to your AI agent and ask it to sort the problems out. The same goes for any problems later on. I won't keep stopping on this. I'll be using CLAUDE Code in the terminal. If you prefer doing it in the UI, go ahead. You can use a different agent, that's your choice. I'll be using GitHub Copilot with the GPT model, and the Relief Copilot extension will help me avoid burning through limits too fast, but you'll need to spend 10 minutes setting up the extension following the instructions on its page. If you have a Codex subscription, you can use it instead of GitHub Copilot. You'll also need to install Superpowers for brainstorming your ideas and possibly for code review. I strongly recommend installing OpenSpec or something similar to develop and stick to specifications inside the project. CodeRabbit lets you do a final review before committing. Install the extension in your editor or the CLI. You'll need to authenticate. I'll use the extension for visibility, but this step can easily be automated. This project will be built on TypeScript using Bun. You can pick whatever is closer to you. I also recommend installing skills. These are modules with instructions and templates for specific tasks. Some of them might install globally because they can be useful in other projects. The rest are more specific to this project. All right, now we have everything we need to get started. All this time we've been doing nothing but preparation, and even in this video, we're not getting to actual coding. I warned you, this is not vibe coding. This is coding with AI agents, and the difference is significant. The first thing to do is to describe the project in detail in the about.md file. We'll do that, of course, with the LLM in brainstorming mode. The init.md file already contains a prompt for this. If you've installed Superpowers, this prompt will trigger a brainstorming session inside CLAUDE Code, and you'll be asked a series of questions. It takes a little time, but believe me, questions will come up that you hadn't even thought about. This is a very important step. The next step is writing the basic specifications for your project. Here I prefer to specify the base tech stack and package versions, because if you don't, the LLM will pull them from its own memory, and that will almost certainly be something fairly old. It's also worth remembering that an LLM is quite lazy, and if errors come up while working with packages, the first thing it'll likely do is downgrade the package version and fall back to old approaches. That's exactly why it's important to forbid downgrading versions. The same thing is written in AGENTS.md and CLAUDE.md. We'll get back to that a bit later. When creating the architecture file, it's important to understand that this description is more for you than for the coding agent. Read it carefully after it's generated, and make sure that this is really the architecture you expect to see as the result. Ask the LLM to make corrections if something is off. If you're not confident in architecture, ask the agent to explain every key decision. The places where it starts wriggling and hand-waving are usually where the weak parts hide. Now we can plan the actual development. At this stage, splitting the project into a dozen stories makes no sense. 4 is enough. They cover the whole MVP and give us clear checkpoints. We won't brainstorm the plan, just skim the result. If something doesn't look right, ask the LLM to change it. By the way, if you want to see how this pile of documents turns into real code, and real code into a live product, hit subscribe. The paperwork ends right about here. Commits are next. At this point, we already have 4 quite professional documents that will form the foundation of all further development. I would recommend running them through a review with a different model to polish the wording and catch weak spots, but I don't want to spend your time on that right now, so let's move on. Let's quickly stop on AGENTS.md, and its copy CLAUDE.md. You can copy this file and adapt it for yourself. The easiest way to generate this file from scratch is to run the init command inside Claude code. The first thing to pay attention to, I clearly state that it's April 2026 so that the LLM doesn't try to dig around in the past, which it loves doing. The documentation files generated earlier are also listed here. I already mentioned forbidding version downgrades. It's duplicated here for safety. The section about timeouts is there so the agent doesn't use very long waits when watching background operations. Also, only read-only commands are allowed here. That is restricted more strictly through config files, but it's duplicated here in case you use different coding agents. I won't dwell on TDD for long. Let me put it straight. When the test is written before the code, it checks what the code is supposed to do, not what it already happens to do. Tests like that actually catch bugs instead of just painting a green checkmark on the report. Next, we allow the agent to find skills for the project with a preliminary check of the skills that are already installed. Using subagents is a useful feature for faster development. And the last instruction, listing used skills and docs in the final report so you can understand what the agent actually based its work on. Last but not least, if you're going to work with GitHub Copilot, you should also copy the .github folder. Inside it there are pre-configured subagents and instructions that let you work with this agent effectively. Reminder once again, you must have Relief Copilot configured per its instructions. If you're not using GitHub Copilot, just skip this step. You may notice that the project has Agents and Claude folders, which appeared after skills were installed. The skills inside Claude are just symlinks to the skills in Agents. Pretty much every coding agent uses the Agents folder. Claude Code is an unfortunate exception. Same story with Agents.md. There are also a few other configuration files in the project which we don't need right now, but will be useful later. You may also notice the files workflow.md and prompts.md. We don't need them right now, but they are exactly what our working process will be built on when we move on to implementing the project, that is, in the next videos. We're almost at the finish line. Let's initialize OpenSpec, which will let us develop the project exactly as it was planned, giving the LLM fewer reasons to hallucinate. We just run the OpenSpec init command, pick our coding agents, and end up with the corresponding skills added and a stub config file, which we won't configure. OpenSpec works great out of the box. So, we've laid a really solid foundation for our project. I warned twice, this is not a fast process. Both developers and construction workers know perfectly well that the stronger the foundation, the more reliable the final product. In the next video, we'll start the actual development. Subscribe so you don't miss it.